be able to define acid and acid anhydride. And second of all, another objective is the ability to investigate the reaction of non-oxidizing acids with metals, carbonates, hydrogen carbonates, and bases. You should be able to define bases and alkali at the end of this class. Um, Investigate the research or reaction of bases with ammonium salts. Relate acidity and alkaline to the pH scale. Discuss the strength of acid and alkalis on the basis of their completeness of ionization. Define acid, base, phosphoric and nutric acid or neutral acids. So these are some of the things that you should learn at the end of this class. So without further ado, let's actually start. So define salt also and identify the appropriate method of salt preparation based on the solubility of the salt. Distinguish between acidic and normal salts. Investigate neutralization reaction using indicators and temperature changes. So the first basic definition are water acid. Fruits like apples, oranges, and pineapples taste sour because they contain acids. Acids also turn blue litmus paper red, and acid have hydrogen ions H plus in water. So, for example, apples, oranges, and these things taste like a bit sour because they contain acid. So, as we said, acids produce hydrogen ions in water. So, this is the basic definition of what is an acid. An acid is a substance which produces hydrogen ions or H aqueous in water. So when we put an acid in a water that produces H ions in the water, for example, hydrochloric acid dissolves in water to form hydrogen ions and chlorine ions. So HCl, when we actually add the acid into it, it equals to H plus aqueous plus the chlorine ions, AQ or aqueous, and it is the hydrogen ions which turn blue litmus to red and give acids their characteristic properties. So it is really the hydrogen ions that gives that the litmus paper that blue litmus red to red and gives acid their characteristic properties. So what are acid or what are the chemical properties of acid? Acids react with metals to produce hydrogen gas. Um, for example, with the magnesium plus H2SO with the small 4 equals MgSO4 plus the H2 or hydrogen to the small power of 2 or 2 scripted. So acids react with carbonates, produce carbon dioxide and such alike. So from the two waters, you could see or you could test for hydrogen gas in the following ways. And it usually gives a pop when you're lighting, for example, in the lab you have your apparatus ready and you could actually test for hydrogen gas in that manner. So, other chemical properties of acid. Acids react with bases to form a salt and water only, and this is always definitive, right? So when acids react with bases, it always form a salt and water solution all the time. Example, sulfuric acid reacts with copper iodide to form a salt called copper sulfate and water. So as we could see from the from the reaction that the water is formed reaction. This reaction is called the neutralizational point, I little call it. So a strong acid is an acid that is completely ionized in water. This means that all the acid molecules become ions in the water. So when it's a strong acid goes into water, examples of strong acid are sulfuric acid, hydrochloric acid, and nitric acid. This means that all the acid molecules become ions in the water. So, what is the definition of a weak acid now? So, a weak acid is an acid that is only partially ionized in water. So, you could see the difference in the container as we could see on the right hand side. So this means that only a few molecules of acid become ionized in the water. In the case of a strong acid, a lot of molecules become ions in the water. Example of weak acids are ethanoic acid, citric acid, and carbonic acid. So some common acids is, for example, the sulfuric acid, which is the H2SO4, and we have the hydrochloric acid, which is HCl. Hydrochloric acid is quite common. the nitric acid HNO3, the citric acid C6H8O7, and the ethanoic acid vinegar CH3COOH. And this is the ethanoic acid vinegar is very common in terms of experimentations in chemistry labs. So you could take down the formula for that now. So, all right, if you have gotten that, let's continue. So the uses of acids. Hydrochloric acid is used in the industry to remove rust from metals before they are painted. So they usually rub acids on the steel bars in order to remove rust before they are painted. Sulfuric acid is used to make fertilizers and detergents in order to make your clothes clean, and it's used to clean objects, clean dirt, and it's very effective in that area. Ethanoic acid is used in vinegar for cooking and to preserve food such as vegetables. Citric acid is used in making fruit salts. So this is quick questions. You could pause the video. What ions do acids produce in water? Stage 3 properties of acids. Explain what is meant by a strong acid. Give one example of a strong acid. Explain what is meant by a weak acid. Give one example of a weak acid. Some dry citric acid crystals are placed on a dry piece of litmus paper. Will there be a color change? Explain your answer. So if you have gotten all the answer there, guys, you could see the answer, the solutions to it, and tell me in the comment below if you have gotten all of that right. So let's continue. So the second part of this class is bases. So a base is an ionized or hydroxide of a metal. Example of bases are sodium oxide, sodium hydroxide, copper II oxide, and copper II hydroxide, etc. A base reacts with an acid to form a salt and water only, and that's something that bases and acids have in similar. They only form salt and water only. So, for example, with this utilizing the same example, we this process is called neutralization. So that's something that you could look at, and you could actually see the silver lining between acids and bases in this case scenario. Moving on, let's look at alkalis. So an alkali is a soluble base which produces hydrogen ions OH negative aqueous in water. So it does not produce positive OH in water. It produces actually negative. So if a base is soluble in water, it is called an alkali. So sodium hydroxide is an alkali because it dissolves in water to produce hydroxide ions. So for example, we have NaOH aqueous equals NaAQ plus OH to the negative. So let's look at the difference between bases and alkali. For example, in a base, copper II hydroxide is a base but not an alkali. This is because it is insoluble in water and hence cannot produce hydroxide ions. So to be a base, it needs to be soluble. No, it needs to be insoluble in water. But to be an alkali, it needs to be soluble in water. So is this true? You could tell me if it's true in the comments below. All alkali are bases, but not all bases are alkalis. You could tell me that idea in the comment below. Tell me if it's right, or tell me if you believe it's true or false. So on table 4.1, which is solubility guidelines for common ionic compounds in water. So let's look at the soluble ionic compounds or compounds containing. So important exceptions. You could look at the graph there. You could take it down. This is a very important graph. Um, so take it down if you have gotten that in your books. Let's continue in the explanation of process. I will come back to this on a later video explaining the importance of it and giving it full details. But for now, take that down. All right, if you have gotten that, let's move on. So chemical properties of alkalis. So alkalis have a bitter taste and soapy feel. And secondly, alkalis turn red to blue to litmus blue. Alkalis react with acids to form salt and water only. You could look at the examples below. So let's look at the chemical properties of alkalis. Alkalis react with ammonium salts to produce ammonium gas. And secondly, ammonium gas is acidic, thus it turns red, litmus paper blue. Third, ammonia gas is very soluble in water and gives out a pungent smell. Example, NOH plus N4CI. As we said before, it always forms the water and salt only base. If you look in the diagram below, the sodium hydroxide plus the ammonium chloride, NH3 gas produce turns red, litmus blue, and this is the chemical properties of the alkalis in a chemical reaction. So, in relation to everything else, let's look at some of the practical uses of bases. So, sodium hydroxide and potassium hydroxide are used in making soaps. You would usually do this in your chemistry lab book. So, I will utilize a sample of that in a later video to actually explain the process in actually creating soaps using potassium hydroxide and sodium hydroxide. So, secondly, ammonia solution is used in window cleaners. Magnesium hydroxide is used in toothpaste to neutralize the acid produced by bacteria. And finally, calcium hydroxide or slaked lime is used to neutralize acids found in acidic soil. Some common alkalis include the sodium hydroxide, which is NaOH, potassium hydroxide, NaOH, or KOH, sorry for that, calcium hydroxide, CaOH2, and we have ammonium solution or ammonium hydroxide, NH3 aqueous. So I'll give you a couple seconds to write down the chemical formula and the name of these elements so that when we're going to answer the set of other questions, you can get all correct. One, two, three, go. If you have gotten everything, if you have gotten the notes, let's move on. So let's pause it a couple of seconds, answer the questions, and tell me if you have gotten all right. Let me start the countdown. One, two, three. Pause the video, and let's wait and let's see your answers. All right, guys. If you have gotten all the answers for that, let's move on. So these are the solutions to the quick check or question two or the second set of questions. Tell me if you have gotten all right in the comment below. All right, guys, let's move on. So another important part is indicators, and indicators show the acidity of or the coloration or the acidity and differentiation between different elements to know of how acidic or how alkaline solutions are. So indicators are substances which show different colors in acidic and alkaline solutions. Litmus is a common indicator as shown in, we call that litmus paper. It is red in acidic solutions and blue in alkaline solutions. Other important indicators are shown in the table on the other side. So other indicators including methylene orange, litmus, and the phenolphthalein. Um, so the color in strong acids include red, litmus red, and if it's in the third one, which is phenolphthalein, is colorless. So pH at which color changes. So color in strong alkalis, it is the average of pH 4 for the methylene orange, pH 7 in litmus, it turns actually blue, and in the final one, which is the phenolphthalein, it turns pink, which is the average of pH 9. So it changes at average around pH 9 for the final one. The methylene or the methyl orange that turns yellow at pH 4, and the litmus turns blue at pH 7. So the pH scale. The pH scale ranges from the scale of 0 to 14, 7 being the neutralizational point, which is usually water. And so the pH of a solution tells us how acidic or how alkaline a solution is. The pH is a measurement of the hydrogen ion concentration in a solution. So the pH of a solution can be measured with a pH meter. So the lower the pH, the more acidic the solution is. So between 1 to 6, that's within the acidic range. The pH that is more alkaline solution is pH, it is neutral. So if it's higher than that, it is more alkaline. If it's below the pH of 7 or 6 to 1, it's it's more acidic. So distilled water, sugar solution, and most salt solution are neutral or pH 7. So if you could look at it, the universal indicator consists of a mixture of dyes which changes its color in different pH solutions. We can use the universal indicator to tell us the approximate pH of a solution. So if you could take a look at the picture below, it shows the coloration of um, the different reactions at different pH levels. So if within pH 4.0, which is quite acidic, it turns red. pH 5, it turns a bit pink. Um, and you could see the coloration. I allow you some time to look at that. And the pH 11, that turns mainly purplish, or a dark purple. pH 10, which turns a light purple. And the coloration is across the whole board. So without further ado, let's move on. So let's look at the type of oxides, and we will close out for here today. So elements born react with oxygen to form oxides, and there are four types of oxide, including acidic oxides, basic oxides, and amphoteric oxides and neutral oxide. An acidic oxide is an oxide of non-metal. It dissolves in water to form an acid. Acidic oxide react with alkalis to form salts. So an basic oxide is an oxide of a metal. If soluble, it dissolves in water to form an alkali. Basic oxides react with acids to form salt. So an amphoteric acid is an acid which can react with both acids and alkalis to form salts. While at the end of the day, a neutral oxide does not react with either acid or salts. It's quite of like similar to like a noble gas, as we discussed in the last class. So if you could look at the diagram, if you look at the diagram, these are the type of oxides: basic oxides, acidic oxides, amphoteric oxides, and neutral oxides. And with that, we'll close off right there. You could take a look at the diagram. There will be a part two going in depth with more explanation and points so that you could really understand the full concept down to its bone. So these are some of the quick questions. I'll give you a couple seconds to answer that. All right, guys, if you have